Okay, we'll look at some of the sample calculator activity problems, and I'll do these so that you can get an understanding of how to use the graphing calculator for these type of problems. In problem number one, you're asked to use the graphing calculator to graph the quadratic function f of x is equal to x squared plus 4x minus 5, and you want to find the coordinates of the vertex. Okay, so here in this case here, we'll look at how that's going to be done. Okay, now to enter a new equation, you want to press y equal, and any equations that you have in y1, like I have here, you just press the clear key, and then you'll type in your equation x squared plus 4x minus 5. Your xt theta is this button here, and then the x squared button for the exponent of 2, then plus 4x minus 5. Okay, now we're going to do the graph of this particular quadratic function. So you'll press the zoom key, which is the third key on the top, at the very top, and then select number 6, which is your Z standard. That's going to give you the standard window. And this represents the graph of that particular equation, f of x is equal to x squared plus 4x minus 5. Now here we want to find the coordinates of the vertex, which means in this case, the vertex is the lowest point on this graph. So here we're finding the minimum. So what we want to do here is select second, which is the blue key or the yellow key, depending upon what calculator you have, and then trace. Press second and then trace, which is the fourth key on the very top row next to your window. Now we want to find the minimum, which is a vertex, so we select number 3. And then you should get this message that says left bound. What you want to do is position the cursor on the left-hand side of the lowest point using your left arrow key. Somewhere on the left-hand side. Once you're done with that, go ahead and press enter. Then you should get a message that says right bound. You want to use your right arrow key to position the cursor on the right-hand side of the lowest point. And then press enter. Then after guess, go ahead and press enter. And that will be your vertex. X is -2 and y is -9. So in this case, the coordinates of that vertex will be -2, -9. Those are the coordinates of the vertex. Now, the other part of that problem says this. Based on this result, you want to write the quadratic function in standard form, and you're going to let a equal to 1. If you recall, standard form of a quadratic equation is this. Y is equal to a times the quantity x minus h, and that's squared, plus k. And in this case, h and k are the coordinates of the vertex. So when we found the vertex of -2, -9, your h is -2, and the k is -9. I'm sorry, h is -2, k is -9. And we're letting a equal to 1. So in this case here, we'll have y is equal to, we'll replace the a with 1, times x minus h, in this case is -2. So we get x minus -2 plus k, which is -9. Now if I rewrite this a bit, we're going to have this equation, y is equal to the quantity. Now I left off my exponent of 2. Y is equal to the quantity of x. X minus the -2 is the same as x plus 2, quantity squared. And I'll say minus 9. This will be the equation of that particular, the equation for that graph written in standard form. Y is equal to the quantity of x plus 2 squared minus 9. All right, number 2 is finding the zeros of the polynomial function f of x is equal to x cubed minus 4x squared plus 7. So here we want to find the zeros of this polynomial function, and here they're going to be 3 zeros because the highest exponent here is a 3. So in this case here, they're going to be 3 x-intercepts. So here's what we need to do here. Using our graphing calculator, we're going to press the y equal. We're going to clear out that equation in y1, and then we're going to enter x to the third. So to do that, we press the xt theta for your x. We use the caret key for the exponent of 3, then minus 4, hit your xt theta for your x, and then x squared for the exponent of 2, plus 7. Okay, that's your equation. And then you'll hit zoom, and then 6. And that will be the graph of that particular equation. And as you can see here in this particular problem, we have 3 x-intercepts. Those are the zeros of this particular function. So we have to find the zeros of each one. We'll start with the one on the far left-hand side. And we'll do that by pressing second and trace. Now this time we're finding the zeros, so we're going to select number 2 for the zeros. And you should get a message that says left bound. Now, the blinking cursor needs to be placed below the first x-intercept. So, using your left arrow key to position the cursor somewhere below the first x-intercept, then press enter on your calculator. You'll get right bound, and then you want to position the cursor above that first x-intercept. So, use your right arrow key to put the cursor above it, and then press enter. And then after guess, go ahead and press enter. And that's going to be your first zero there, negative 1.16. Now here we're going to round to 2 decimal places. So here, our first x-intercept is negative 1.16. Now we want our other x-intercept. In this case here, the one in the middle is what we're going to find. So now we want to put the cursor above and below. So we press second and trace, and then select number 2. Now, the cursor needs to be above the second x-intercept, like I have here. Using your right arrow key, you put the cursor above the second x-intercept, and then press enter. And then, after you get right bound as your message, put the cursor below it, using your right arrow key. And then press enter. And then after guess, go ahead and press enter. That would be your second x-intercept, which is in this case 1.77. So the second x-intercept in this case will be 1.77. That's your second x-intercept. Now for the third x-intercept, which is this one on the right side, the cursor needs to be below and above again. So we'll do second, trace, select number 2, and then put the cursor below it, then press enter, and then for right bound, put the cursor above it, and then press enter. And then after guess, go ahead and press enter, and that will be your third x-intercept, 3.39. So these are my 3 x-intercepts, or 3 zeros of this polynomial function. X is equal to negative 1.16, x is equal to 1.77, and x is equal to 3.39. Okay, now number 3. Here we want to determine the end behavior of each polynomial function, considering the leading coefficient considering its leading term a sub n, x sub n. That's whether a sub n is positive or negative, and whether n is even or odd. Show the end behavior using arrows. For example, as you can see, the down and the up arrow for falling to the left and rising to the right, and explain your answer. Then make a graph of the function using the graphing calculator to confirm your prediction, and then draw the shape of the graph. So in this case here, in part A, you got f of x is equal to negative 3x to the third minus x plus 4. In this case here, we need to identify what n is. N is always your highest exponent of this particular polynomial function. In this case here, the highest exponent is 3. So here n is going to be 3. A sub n is the leading coefficient. And of course, the leading coefficient is always the coefficient of the variable with the highest exponent. So in this case, it's negative 3. So a sub n is negative 3. From that, we can determine what the end behavior is going to be. N is odd, and a sub n is negative. So in this case here, the graph of that particular function, f of x, will be rising to the left and falling to the right. And to confirm that, we can do the graph of that particular function on the calculator. And here's how we'll do that. Just press y equal and clear this equation out. Then negative 3x cubed, negative. The negative key is at the very bottom. Then 3, x, t theta for your x, your caret key for your exponent, and then 3 minus x plus 4. Then press zoom, and then 6. As you can see, this graph is rising to the left and falling to the right. So it does confirm that the end behavior of that particular function, it rises to the left and falls to the right. Now, part B is a g of x equals x to the fourth minus 6x squared plus 6. Okay, if we identify what n is your highest exponent in this particular polynomial function. That's 4. Your a sub n, that's your leading coefficient, which is in this case 1. Now here n is an even number and a sub n is positive. So that means that this function, or the end behavior of this function, rises to the left and rises to the right. Now to confirm that, we'll just type in that function. Press y equal, clear that equation out. Then x to the fourth will be x, and then your caret key, and then 4 minus 6, then x, and then hit the x squared button, plus 6. And then zoom 6. And as you can see, the end behavior, it rises to the left and to the right. Okay. Problem number 4 is using a graphing calculator to determine the two intervals on which the polynomial function f of x is equal to x cubed minus 4x minus 6 is increasing, and the one interval on which it is decreasing. Okay. Let's go ahead and graph this equation in the calculator. So here we got, press y equal, and then clear the equation out. And then x cubed will be your xt theta, the caret key for your exponent, and then 3 minus 4x minus 6. And then zoom 6. Okay, and that's our graph. Now we want to find out where is it increasing and where it is decreasing. Okay, we see that it's increasing up to this highest point right here, and then it's starting to decrease to its lowest point, and then start increasing again. Okay, so here in this case here, let's look at where it's increasing. Let's find this highest point right here. So let's press second, and then trace. We do second, trace, and then the maximum point. We'll select number 4. Now we want a left bound, so we have to put the blinking cursor on the left-hand side of the highest point on that graph, and then press enter. And then for right bound, put the cursor on the right-hand side of the highest point of the graph, and then press enter. Then after guess, go ahead and press enter. Okay, so here we're only looking at the x values here. So we know our maximum is negative 1.15. So the graph is increasing on this interval from negative infinity to negative 1.15. Negative infinity to negative 1.15. It's going to be decreasing from negative 1.15 to whatever this lowest point is. Whatever that lowest point is, that's what I want to find. And whatever that lowest point is, that's going to be part of the interval where it is increasing again. So let's press second and trace. Now we're finding the minimum this time, so we want to select number 3. Now our left bound, we want to put the cursor somewhere close to the lowest point on the left-hand side, and then press enter. Then the right bound, put the cursor on the right-hand side of the lowest point, and then press enter. Then after guess, go ahead and press enter. And that's your other minimum x value, which is in this case 1.15, rounded to 2 decimal places. So we know that it's decreasing from negative 1.15 to positive 1.15. And then after 1.15, it starts increasing to infinity. And notice that I put parentheses here because I'm not including the endpoints here. So this graph increases from negative infinity to negative 1.15, decreases from negative 1.15 to positive 1.15, and increases again from negative 1.15 to infinity. Okay. All right, problem number 5. We're going to algebraically find the equations of the vertical asymptotes of each rational function. And you are required to show your work and then use the graphing calculator to make the graph of the function to confirm your prediction. Then you're going to draw the shape of the graph, which includes the vertical asymptotes. And in this case here, you got f of x is equal to x minus 5 divided by x plus 7. In this case here, we find the vertical asymptote by setting our denominator equal to 0. So we set x plus 7 equal to 0. And then solve for x. So in this case, x is equal to negative 7. So our vertical asymptote is x is equal to negative 7. Okay, and now we want to draw the shape of the graph. So here you do y equal and then clear your equation. Now, for this one, x minus 5, and the x plus 7, I'm going to put in parentheses. So here for left parentheses, I have x minus 5, and then close the parentheses. And then hit your division key, and then left parentheses, x minus 7, close parentheses. And then zoom 6. And here you can see the vertical asymptote here, and that's the graph of the rational function x minus 5 divided by x plus 7. Okay. Now part B, is g of x is equal to 3 minus x over x squared plus 2x minus 24. Now in this case, we got two vertical asymptotes. In this case, we're going to take our denominator and set that equal to 0. So we have x squared plus 2x minus 24, and that's going to be set equal to 0. Now that particular trinomial we can factor into two binomials. So x squared would be like x and x. Now the factors of negative 24 that would give me a positive 2x would have to be plus 6 and a minus 4. Because 6x and a minus 4x would give me a plus 2x. So I got x plus 6 times x minus 4 is equal to 0. And then we set each binomial factor equal to 0. So you have x plus 6 equal to 0 and x minus 4 equal to 0. And then from here we go ahead and solve each one of those equations for x. So for x plus 6 equals 0, you'll have x is equal to negative 6. And then for x minus 4 is equal to 0, you'll have x equals to 4. So you got x equal negative 6 and x equal 4 as your two vertical asymptotes. X equals 6 and x equal 4. Now, let's graph this on the calculator. So we press y equal and then clear that equation. Now, the numerator will be in parentheses. So that would be 3 minus x. So you have left parentheses 3, then minus, and then xt theta for your x. Close your parentheses. Divided by left parentheses x squared plus 2x minus 24. X, then your x squared key for your exponent of 2 plus 2x minus 24, close parentheses. Then press zoom and 6. And in this case, this is what the graph looks like. Now, if you want to get a better looking graph, you can change the window on the y. Let's say from negative 5 to 5. Okay. Okay. That looks a little bit better. But you can see your vertical asymptotes are at 4 and negative 6. Okay. All right, problem number 6 deals with the horizontal asymptotes. Here you want to determine the equation of the horizontal asymptote for each rational function. And you want to compare the leading term degrees n and m. Okay. To determine whether or not you have a horizontal asymptote. And if you do have a horizontal asymptote, what would that equation be? Because it'll be in the form y is equal to something. Okay. And also, you want to use the graphing calculator to make the graph of the function and the horizontal asymptote to confirm your prediction. And you want to draw the shape of the graph, which does include the horizontal asymptotes. So in part A, you got f of x is equal to x squared plus x squared plus 5 divided by negative 2x squared minus 3. All right, we take a look at n, which is the highest exponent in the numerator, which is in this case 2. M is the highest exponent in your denominator. That's also going to be 2. Compare n and m. They are equal to each other. So here n is equal to m. But we want to find out what will be the horizontal asymptote. In this case, when n is equal to m, we always look at our leading coefficients here. So in this case here, the leading coefficient in the numerator is 8. The leading coefficient in the denominator is negative 2. So here is y is equal to a sub n over b sub m, which is in this case 8 over negative 2, which is negative 4. So the equation y is equal to -4 is your horizontal asymptote. Okay? Now, if you recall back in section 3.5, when n is equal to m, we always look at the leading coefficients for our horizontal asymptote. So 8 divided by -2, that's going to be -4. So the equation y is equal to -4 is your horizontal asymptote. All right, part B, we got g of x is equal to x squared minus 4 divided by 2x to the fourth plus 3. In this case here, we look at n, which is the highest exponent in the numerator, that's 2. M is the highest exponent in your denominator, that's 4. Compare n with m. N is 2, m is 4. N is less than m. And when n is less than m, our equation for the horizontal asymptote will always be y is equal to 0. In other words, the x-axis will be your horizontal asymptote. And then finally, for h of x is equal to x cubed divided by x squared minus 4, we identify n, which is going to be the highest exponent in the numerator, that's your 3. Your m is the highest exponent in your denominator, that's 2. Compare n with m. Here n is bigger than m, 3 is bigger than 2, so we say n is greater than m. And when our n is greater than m, that means that the equation for the horizontal asymptote, there is none, because n is bigger than m. That means that there's no horizontal asymptote. And I might as well do the graph for each one of those. So in part A, we press the y equal, clear this out, and then left parentheses, that 8x squared plus 5, close parentheses, divided by, left parentheses, -2x squared minus 3, close parentheses. And then we go ahead and press zoom 6. That's the graph of the function. Now, let's add that horizontal asymptote of y is equal to -4. So in y2, we type in -4 and then press graph again. And there you'll see the equation of the graph of the rational function with that horizontal asymptote of y is equal to -4. Now for part G, where you got x squared minus 4 divided by 2x to the fourth plus 3. Okay, let's clear both of these equations out. And then we'll do x squared minus 4. Now, keep in mind the numerator and the denominator, I'm using parentheses, divided by 2x to the fourth, 2x, and then use your caret key for your exponent of 4 plus 3, and then close your parentheses. And then for y2, our horizontal asymptote was 0, so we'll use 0 there. And then press graph. And as you can see, that is a very small graph for that particular function. And then for your h of x, we know that there's no horizontal asymptote, so we won't have to worry about putting in a horizontal asymptote there, so clear both of those equations out. Let's see, left parentheses 8x to the third, that's this, divided by, then left parentheses x squared will be x, and then your exponent for 2, pressing the x squared button, minus 4, close parentheses, and then zoom 6. And that's what the graph of that equation looks like. Okay. All right. Now, number 7. Here we're going to explain by comparing n and m, as in the previous problem, what you expect the rational function f of x is equal to x squared plus 4x minus 1 divided by x plus 3 to have an oblique or slant asymptote. Find the equation of the oblique asymptote algebraically and show your work. Then use the graphing calculator to make a graph of the function and the oblique asymptote to confirm your prediction. Draw the shape of the graph, and that includes the oblique asymptote. Okay, let's do this algebraically. If you compare n and m, n is 2, that's the highest exponent in your numerator, with m, that's the highest exponent in your denominator, that's going to be 1. Notice that 2 is bigger than 1. Not only that, 2 is 1 more than 1. Here, the highest exponent in the numerator is 1 more than the highest exponent in your denominator. So here, this does have a oblique asymptote because we can say that the exponent in the numerator is 1 more, I should say the degree, which is always the highest exponent. The degree in the numerator is 1 more than the degree, or the highest exponent, of your denominator. Okay. The degree in the numerator is 1 more than the degree in your denominator. In this case, 2 is 1 more than 1, as you can see. Now, to find the oblique, slant, or slant asymptote, we're going to use synthetic division. And if you recall synthetic division, our divisor is x plus 3. That means we take the opposite sign. That's negative. In x squared plus 4x minus 1, there are no missing terms. So the coefficient of x squared is 1. The coefficient of x is 4. And the constant is negative 1. And this is how we set up the synthetic division process. We bring down the leading coefficient, which is 1, in the bottom row. Multiply 1 times negative 3. That'd be negative 3. And then add 4 and negative 3 together, you'll get 1. And then multiply 1 times negative 3, which will be negative 3. Then negative 1 plus negative 3 will be negative 4. Okay? Now, if you recall, the last number in the last row is the remainder. Now, for this particular case, we're going to drop the remainder. It's the quotient that represents your equation of the oblique or slant asymptote. In this case, the quotient is always one exponent less than the highest exponent in your numerator. Our numerator was x squared, so the quotient will start off as this 1 being the coefficient of x, and then the 1 would be your constant, so that'd be plus 1. And it will have the equation y is equal to x plus 1. So the slant asymptote will have the equation y is equal to x plus 1. Okay, now we need to draw the shape of that graph. Let's go ahead and clear that equation out. And we're going to type in that equation, x squared plus 4x minus 1, in parentheses, that's your numerator, x, then the x squared button, plus 4x minus 1, close the parentheses. That's divided by, then left parentheses, your denominator, x plus 3. And then in y2, I'm going to put in that equation of the slant asymptote, which is y is equal to x plus 1. So in y2, I'll just enter x plus 1. And then zoom 6. And notice that's the graph of this rational function That line right there, that represents your slant asymptote of y is equal to x plus 1. And this vertical line represents the vertical asymptote for this particular graph, which is x equals negative 3. Okay? So this should be enough to assist you with some of the problems that are on the actual calculator activity number 3. And if you do have any questions, I'll be able to answer them either after class, or you can come by my office for additional assistance.